Hello viewers, welcome to my channel. I'm Hasham. Last video I have explained you about crashing, that is time cost trade-off in network analysis. So many a times a project manager has to decide whether to crash the activity duration time by employing additional resources. So many project management requires that the project should be completed before the normal time so that the time saved can be used for doing other jobs. So they want to reduce the cost also. So there is inverse relationship between time and cost. If we reduce the cost, if we reduce the time, the cost will increase. So if we take the longer time, the cost will be lower. So management has to take the decision whether crashing of the activity duration time should be employed or not. So all these things I have already explained in the last video. Now in this video, I am going to start the problem on crashing. So if you have not watched the earlier video, I suggest you go to the playlist of my channel. Select the subject Operations Research. Select the video of network analysis, crashing of activities, time cost trade-off. Be clear regarding the concept of this crashing. Then only you should watch the video on problems. So before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points, then I'll explain every point. Now, first problem on crashing. The following table gives the data on normal cost and crash time and cost of a project. The activities consisted of 1 to 2, 1 to 3. The two activities are busting from 1 to 2 and 1 to 3. Then 2 to 4, 3 to 4. So in the fourth event, merging event, 2 to 3, 3 to 4. Very easy, small project. So only 4 activities. Normal cost and normal time is given. So normal time in weeks for first activity 1 to 2, 6 weeks. Second activity 4, 8, 6. These are the normal duration, normal time of activity time. Then normal cost, first activity 7,000, 6,000, 5,000, 9,000. Crash time and crash cost. The crash time are 4 weeks. That means for doing 1 to 2 activity, normal time 6 weeks. But if we crash, the crash time will be 4 weeks. That means how many weeks you are saving? 2 weeks you are saving. But additional cost how much? Normal cost is 7,000 and crash cost is 11,000. 7, 8, 9, 10, 11, 4,000 rupees more we have to incur. So if you want to reduce the time by 2 weeks, additional 4,000 rupees we have to incur for first activity 1 to 2. Similarly 1 to 3, normal time 4 weeks, crash time 2 weeks. That means 2 weeks can be saved. But how much additional cost? Normal cost is 6,000 and crash cost is 9,000. 3,000 rupees more we have to incur, right? Like this, the data is given. Draw the network and identify the critical path with a double line. This is as usual. We have to draw the diagram, calculate EST, LFT value, calculate the critical path and duration. What is the normal project duration and associated cost? What is the normal cost and what is the normal duration of completing the project? Second, crash the relevant activities systematically and determine the optimal project completion time and cost. These 3 questions. So compared to previous problem, this problem consisted of cost also. In the previous videos, we have done the problems on network analysis where time was given but cost was not given. Here cost is also given because these problems are trade-off between time and cost. Now, first of all, we will draw the network diagram. 1 to 2 and 1 to 3, 2 to 4, 3 to 4. That's all. This is the diagram. Now duration, normal duration, remember we are not taking the crash, we are taking the normal duration. The normal time for 1 to 2 is 6, 1 to 3 is 4, 2 to 4 is 8 and 3 to 4 is 6. These are the normal times given. Now we calculate EST value, forward pass. 0 plus 6 is 6, 0 plus 4 is 4. Now here two arrows are merging, so we take the maximum. 6 plus 8, 14, or 4 plus 6, 10. 14 or 10, whichever is higher, 14 is higher. EST completed. Now LFT, backward pass, 14. Here only one arrow is busting, so 14 minus 6 is 8. Here only one arrow is busting, so 14 minus 8 is 6. Now here two arrows are busting, so we take the minimum. 6 minus 6, 0, or 8 minus 4 is 4. 0 or 4, whichever is lower, 0 is lower. That's it. Critical path is the longest path from first to last event where EST, LFT value should be same. Here it is not same, 4 and 8 are different. Here it is same. So the critical path goes from 1 to 2, 2 to 4. That's it. Only two critical activities. 1 to 2 is the activity and 2 to 4 is the activity. And project duration time is 14 weeks. So here the network for normal distribution, normal duration time indicates a project time of 14 weeks with a critical path of 1 to 2, 2 to 4. As shown by double lines in this diagram. Normal duration 14 weeks and normal cost. Normal cost is given in the problem. Add up all the costs, 7,000 plus 6,000 plus 5,000 plus 9,000. Add up all the normal cost, we'll get 27,000. So 27,000 is the normal cost, 14 weeks is the normal duration of completing the project. Now for critical activities, cost slope needs to be calculated. What do you mean by cost slope? The additional cost or extra cost incurred per week. Here time unit is week. So what is the additional cost to crash the activity per week? Right? That's what we have to calculate. Only for critical activities we have to consider, because total duration of the project can be reduced only by crashing critical activities. If non-critical activities are crashed, no project duration will not decrease. Now here, activity 1 to 2, 1 to 3, 2 to 4, 3 to 4 given in the problem. NC, normal cost. Normal cost is given 7,000, 6,000, 5,000, 9,000, whatever is given in the problem. CC, crash cost. The crash cost is 11,000, 9,000, 7,000, 14,000. Normal time 6 weeks, 4, 8, 6. Crash time 4, 2, 6, 4. So all this data is given in the problem. Normal cost, crash cost, normal time, crash time. Now time saved. Normal time 6 weeks, crash time 4 weeks. How many weeks we can save? 2 weeks. 4, 2, 2 weeks. 8, 6, 2 weeks. 6, 4, 2 weeks. These are the times saved. Now additional cost. How much extra cost? So normal cost is 7,000, crash cost 11,000. So 11,000 minus 7,000 is 4,000. This 4,000 is the additional cost. Right? Similarly, 9,000 minus 6,000, 3,000. 7 minus 5, 2. 14 minus 9, 5,000. These are the additional cost. Now cost slope is equal to additional cost divided by time saved. Write down the formula. While watching the video, always keep ready the notebook, pencil, calculator, everything ready. Whenever I say something important, immediately note it down. Then only you can be able to remember, then only you can be able to get a good command on the concept, on the problems. So here, cost slope means additional cost divided by time saved. So 4,000 divided by 2, 2,000. 3,000 divided by 2, 1,500. 2,000 divided by 2, 1,000. 5,000 divided by 2, 2,500. But we need the cost slope only for critical activities. The critical activities are 1 to 2 and 2 to 4. This is 1 to 2 and 2 to 4. Only these two critical activities we need cost slope. The cost slope 1 to 2 cost slope 2000 and 2 to 4 cost slope is 1000. We are not concerned with 1500 and 2500. Only these two we have to consider. Now we crash that activity whose cost slope is less. The cost slope is only 1000. For which activity? 2 to 4. 2 to 4 activity will crash because the cost slope is less. Right? So how many weeks we can crash? 2 weeks. Actual normal time is 8 weeks. But we can complete the activity in 6 weeks. So how many weeks? 2 weeks. So every week how much? 1000. Additional 1000 rupees we have to incur for 2 weeks, 2000. So here we crash the activity 2 to 4 by 2 weeks, incurring an additional cost of 2000. Additional cost 2000 we are incurring. 1000 into 2. Right? Network after crashing. Now remember, whichever activity is crashed, that duration will write on first. Here we are crashing activity 2 to 4. So 2 to 4, what was the earlier crash, time? Normal time? 8 weeks. Now we are crashing this 8 weeks by 2 weeks. So new time will be 6 weeks. So for 2 to 4 activity, we are taking 6. Earlier it was 8. Now we have crashed by 2 weeks, it is 6. Other times remain same. The other times are 6, 4, 6. 6, 4, 6. That's it. Now we find out the EST LFT value. So 0 plus 6 is 6. 0 plus 4 is 4. Here 6 plus 6, 12, or 4 plus 6 is 10. 12 or 10, whichever is higher. 12 is higher. 6 plus 6 is 12. Now reverse back. 12 minus 6 is 6. 12 minus 6 is 6. Right? Here two arrows are busting. 6 minus 6, 0. 6 minus 4 is 2. Whichever is lower. 0 is lower. That's all. Again we got the critical path 1 to 2 to 1 to 4 because 4 and 6 are different. So these two activities are not critical. Now critical activities are 1 to 2, 2 to 4. And the total duration will be 12 weeks. Earlier it was 14 weeks. We have crashed. Now again critical path is 1 to 2, 2 to 4. There is a possibility of again crashing. So we have crashed the activity 2 to 4. What is the next critical activity? 1 to 2. 1 to 2 is the critical activity. So 2000 is the slope, right? So actually normal time is 6 weeks, crash time 4 weeks. So how many weeks we can crash? 2 weeks we can crash. So per week 2000, for 2 weeks 4000. So we can say now we crash the activity 1 to 2 by 2 weeks, incurring an additional cost of 4000. So now we crash the activity 1 to 2 by 2 weeks, incurring an additional cost of 4000. 2000 per week into 2, 4000. Now see what is the network. Which activity we have crashed? 1 to 2 activity we have crashed. The earlier time was 6 weeks. Now we have reduced by 2. So instead of 6, we will take 4. Now instead of 6, we will take 4. We have reduced 6 to 4. Right? Remaining other times same. So this is 6, 4, 6. 6, 4, 6. Only 1 to 2 activity time is changed. Now again we calculate EST. 0 plus 4, 4. 0 plus 4, 4. Right? Two activities are merging. 4 plus 6, 10. 4 plus 6, 10. Now backward pass, LFT. 10 minus 6, 4. 10 minus 6, 4. Now two activities are busting, so we take the minimum. 4 minus 4, 0. 4 minus 4, 0. Now what do you see here? All the activities EST, LFT values are same. And all the paths are critical. 4 plus 6, 10. And 4 plus 6, 10. The question of further crashing is not possible since all activities have become critical. Duration 10 weeks. There is no possibility of further crashing because all activities have become critical. So the total cost of the project is, what is the normal cost we have incurring? 27,000. What are the additional cost? First time when we crash, the additional cost was 2000. Second time when we crash, the additional cost was 4000. So this 2000, this 4000, 6000. So 27,000 plus 2000 plus 4000. It comes to 33,000. That's it. We have completed the answer. That means the project should be crashed. Normal time was 14 weeks. But crash to time is 10 weeks only. But normal cost is 27,000. The crash cost, total cost will be 33,000. Now you'll get in mind the cost have increased, no? But we have not considered the indirect cost. Indirect cost will decrease. Here in the problem, indirect cost is not given. We are given only direct cost. So we suggest that crashing should be done up to 10 weeks. The total cost, the direct cost will be only 33, indirect cost not given in the problem. That's it. This is the first problem end on crashing. Now, second problem. For the data given below, activity 1 to 2, 1 to 3, 2 to 3, 2 to 4, 3 to 4. Duration, normal duration 5 days. Time is given in days. 5, 9, 6, 10, 6. And normal cost rupees 170, 310, 80, 130, 110. Crash duration 4 days, 6 days, 4, 8, 4. Cost 240, 550, 200, 230, 290. We are given normal time, normal cost, crash time, crash cost. Indirect cost for the project is 120 per day. Previous problem indirect cost was not given, only direct was given. But here indirect per day 120 rupees. Draw the network of the project. What is the normal duration and cost of the project? Find the optimum duration and corresponding minimum cost. 3 questions are asked. First of all, we are required to draw the network diagram. See here carefully. Second project, 1 to 2, 1 to 3. The project consists of activities 1 to 2, 1 to 3. Then 2 to 3, 2 to 4. So 2 to 3 coming down this arrow. And 2 to 4. Then lastly 3 to 4. The fourth event is the last event combined. That's it. Network diagram we have drawn. Whatever normal duration, that normal duration we take it on the activities. 5, 10, 9, 6, 6. Normal duration. Now we calculate EST LFT value. So 0 plus 5 is 5. 0 plus 9. Here 2 arrows are merging. Here 2 arrows are merging. So we take the maximum. Here 5 plus 6, 11. Or 0 plus 9 is 9. 11 or 9, whichever is higher. So 11 is higher. Here 2 arrows are merging. So we take the maximum. 5 plus 10, 15. Or 11 plus 6, 17. 17 or 15, whichever is higher. 17 is higher. EST completed. Now LFT, backward pass. Here 17 minus 6 is 11. Here 2 arrows are busting. So we take the minimum. 17 minus 10 is 7. Or 11 minus 6 is 5. So 7 or 5, whichever is lower, 5 is lower. Here 2 arrows are busting. So we take the minimum. 5 minus 5, 0. Or 11 minus 9 is 2. So whichever is lower, 0 is lower. That's it. We got all the EST LFT value. Critical path is the longest path where EST LFT values are same. So here all the values are same. But this path is not critical. Because if you add up 0 plus 9 plus 6, 15. So this is come to 15 only if we go this path. Right? Here also if we go this path, this is also not critical. 5 plus 10, 15. We are having 17 here. The critical path is 1 to 2, 2 to 3, 3 to 4. So 5 plus 6, 11. 11 plus 6, 17. That's it. The critical path is shown by double lines. 1 to 2, 2 to 3, 3 to 4. Duration of the project is 17 days. Right? Direct cost. Total direct cost is the normal cost. So normal cost is given in the problem 170, 310, 80, 130, 110, total 800. And indirect cost per day 120 rupees. And how many days the project takes? 17 days. So 17 into 120, it comes to 2040. 2040 is the indirect cost and direct cost is 800. The total cost 800 plus 2040, 2840 is the total cost. If we complete the project in normal time, no crashing, normal time, right? Critical path is 1 to 2, 2 to 3, 3 to 4. Now, in order to crash the activities, we need cost slope. Cost slope requires activity normal cost, crash cost, normal time, crash time. All these are given in the problem. Now time saved. Normal time 5 days, crash time 4 days. So how many days are saved? 1 day. 9 minus 6, 3. 6 minus 4, 2. 10 minus 8, 2. 6 minus 4, 2. Time saved. Now additional cost. Crash cost minus normal cost. Crash cost 240 minus 170, 70. 550 minus 310, 240. 200 minus 80, 120. 230 minus 130, 100. 290 minus 110, 180. We got additional cost. Now cost slope. Cost slope is equal to additional cost divided by time saved. Additional cost divided by time saved. 70 divided by 1 is 70. 240 divided by 3, 80. 120 divided by 2, 60. 100 divided by 2, 50. 180 divided by 2, 90. All the cost slope we have calculated, but we need the cost slope of only critical activities, not all. So critical activities are 1 to 2. So 1 to 2, I have put asterisk mark here. We have to consider 70. Then 2 to 3. 2 to 3 is 60. And 3 to 4. 3 to 4 is 90. So we need the cost slope of only critical activities, and the cost slope are 70, 60 and 90. So whichever cost slope is minimum, that activity should be crashed. So 70, 60, 90. 60 is minimum. For which activity? 2 to 3. So we crash the activity 2 to 3 by 2 days, incurring an additional cost of 120. So here we crash the activity 2 to 3 by 2 days, incurring an additional cost of 120, 60 into 2. So which activity we are crashing? 2 to 3. See here. So 2 to 3, this is 2 to 3. Earlier it was 6 days. Now we are crashing by 2 days. So 6 minus 2, 4 days. So here I have taken 4 days. Here I have taken 4 days, keeping all other days same. So this 5, 9, 5, 9, 10, 6, 10, 6. Only 2 to 3 activity we have reduced, crashed. Now we find out again EST, LFT value. So 0 plus 5 is 5. Here two arrows are merging. So we take the maximum. So 5 plus 4, 9, or 0 plus 9 is 9. So both way we are getting 9. So we have taken 9. Here two arrows are merging. So we take the maximum. 5 plus 10, 15. Or 9 plus 6, 15. EST completed. LFT. 15 minus 10 is 5. Here 15 minus 6 is 9. Here two arrows are busting. So we'll take the minimum. So 15 minus 10 is 5. 9 minus 4 is 5. Here two arrows are busting. So we take the minimum. 5 minus 5 is 0. Or 9 minus 9 is 0. Now we can see all the activities have become critical. How? Because you can see here 1 to 2, 2 to 4, 5 plus 10, 15. If you go down 1 to 3, 3 to 4, you can see 9 plus 6, 15. Or if we go like this 1 to 2, 2 to 3, 3 to 4, 1 to 2 is 5. 5 plus 4, 9, 9 plus 6, 15. So all the activities have become critical. Now there is no possibility of further crashing. Crashing is over. So all activities have become critical. So there is no possibility of further crashing. So minimum duration of the project is 15 days. Originally it was 17 days. Now we have crashed to 15 days. And the minimum cost will be 800 is the normal cost. Normal cost already we have calculated 800 plus additional crash cost. How much we are incurring? 120. So 800 plus 120. This is the direct cost plus indirect cost per day 120 rupees. How many days we are doing the work? 15 days. So 120 into 15 is 1800. So 1800 plus 920, you will get 2720 is the total cost. So without crashing, if we complete in normal time, it is 2840. If we crash the activity, then our total cost will be 2720. That is the benefit the management is getting by crashing the activity. That's it. So in this video, I have explained you two problems on crashing. So if you are satisfied, give a like to the video, share my channel, give your comments, subscribe if you have not yet subscribed, and buy the super thanks which is given below my video. Inshallah, we'll continue the next problem in the next video.